Right, so now we have done one example. We can quicken the pace a bit, right? Okay, so the keyword here, again, it's to factorize the given expression, given cubic polynomial, all right? So what is step one? What is step one? Right, we have to use the factor theorem to find one factor. And for that, we can just use your calculator. Okay, you can use the calculator to help us. But remember, the calculator is just a tool, all right, to help us to only find your first factor. Okay, so you have to show the subsequent working after finding your first factor. So on your calculator, this is calculator. I'm going to use a different color. Okay, on the calculator, what you will see will be x1 equals to -1, x2 equals to 3. Okay, so these are the roots. These are the roots of your cubic curve. Okay, when the cubic curve intersect the x-axis, these are the roots. Right, so we're going to convert it into factor. So you can choose either x equals to -1, 3, or 2. So I think I will just take this. Doesn't matter which one you take. So we need to convert that into a factor. So the factor will be x minus 3. All right, x minus 3 is the factor. Right, so step 1, we've already found our factor, and we're going to give the polynomial a name. We're going to call it gx, g of x. Okay, you can use any other letter if you want to, T, A, B, whatever, any of the 26 alphabets. So, but usually we just use f of x or g of x, because f of x, because f is the first letter of the word function, right? So g of x is equals to x cubed minus 4x squared plus x plus 6. And that will give us your factor, which is x minus 3. And that needs to be multiplied with the quotient. And the remainder, of course, is 0. Okay, because x minus 3 is a factor. According to factor theorem, remainder will be 0. All right. Okay, so you can use long division, or you can use compare coefficients of similar terms. Here, I prefer to use comparing coefficients of the similar terms. Okay, right. So your dividend is degree 3. All right, your divisor is degree 1. Right, hence the quotient got to be degree 2. Okay, and if you were to recall what we have the previous slide, a polynomial with degree 2 will be in the form ax squared plus bx plus c, right? Okay, we have also learned that there are 3 unknowns there, a, b, c. So we can easily find a and c. So you just take the first term of your divisor, multiply with the first term of your quotient. That will give you ax cubed. And this is equals to the first term in your cubic polynomial, which is x cubed here. Right, and then you just divide by x cubed on both sides, you will get a equals to 1. Okay, so we have done it for the constant a. And then how about the constant c? So you just take the last term, multiply with the last term here. Okay, and you will have -3 times c will be -3c, and that will give you +6. So c will be 6 divided by -3, gives you -2. Okay, right. So after you have found the values for a and c, we're just going to substitute into the origin, into the previous line. So a will be 1. So 1 times x squared will just give you x squared plus bx, and then -2. Okay, right. So remember what we said earlier on. To find this constant b, right, you can compare x squared term or you can compare x term. Right, so I'm just going to choose x term. So you just take the first term of your divisor. Okay, x times x squared. We've already done that to get your first term. So we shouldn't be doing that anymore anyway. Okay, so what we should be doing is take x times bx. That gives us bx squared. Well, I think just now we said we want to compare the x term, right? So not keen to have this. Take x times negative 2. Yeah, so that is your negative 2x, which is what we want. All right, and then you go on to your negative 3. You multiply with x squared. No, multiply with bx. Yes, this is what you want. So you will get negative 3bx. And of course, there are also other terms. Basically, there should be 6 terms, but we are not interested to expand all to get all the 6 terms. You just need to compare coefficients of your x term. All right. So your negative 2x minus 3bx, this is compared with who? Compared with this guy here, okay, with the positive x. So you divide by x throughout, you get negative 2 minus 3b equals to 1. And then you simplify it, you will have b equals to, just a minute, negative 2 minus 1. b equals to negative 1. Alright, so therefore your polynomial, okay, I don't have much space here, so I'm just going to continue up here. So your polynomial f of x is equals to, we call it g of x. It's not f of x, we call it g of x. We're so used to calling it f of x. So g of x is equals to x minus 3 bracket x squared minus x minus 2, and I think this one can still be factorized further to get x minus 2 and x plus 1. Let's check if this is, yeah, it's correct here. Remember, the calculator gave us all this. All right. So remember students, the calculator is just a means to help you to find your first ever factor. Subsequently, you have to show, if you're using long division, you have to show the solutions using the long division, or if you prefer like me to use compare coefficient of similar terms, this is what I presented for you.